Hi, good evening everyone. This is Shefali Singla, and in this session we are going to discuss the concept of solving the recurrence relation. So basically there are three methods to solve a recurrence relation. One is the substitution method, recursive tree method and master's theorem. So आज वाले सेशन में हम लोग सिर्फ और सिर्फ सब्सटीट्यूशन मेथड पे फोकस करेंगे बिकॉज आई एम स्टार्टिंग फ्रॉम द सब्सटीट्यूशन मेथड बिकॉज यूजिंग दिस मेथड वी कैन solve any recurrence relation because there is no constraint given. The only thing is if a recurrence relation is having two different parts, then it's might be difficult to use the substitution method. So in that case we'll talk about the recursive tree method. तो जैसे जैसे हम ये तीनों methods discuss करेंगे हमें ज़्यादा clarity आएगी कि why we are using different methods to solve the recurrence relation. Okay? तो सबसे पहले हम लोग discuss करते हैं कि recurrence relation होता क्या है. So can somebody tell me that what is a recurrence relation? Recurrence relation एक टर्म हमें यहाँ पे समझ में आ रही है. recurrence relation आ रहा है हमारे पास recursion के ऊपर से. recursion होता है जब फंक्शन खुद को ही determine करता है, खुद को describe करता है अपनी ही फॉर्म में, अपनी ही वैल्यू में. So recursion is nothing but that's a function call which is making a call to itself. फॉर एग्जाम्पल आपको कुछ एलिमेंट्स को सॉर्ट करना है, तो जो मेथड आप 10 एलिमेंट्स पे अप्लाई करोगे वही सेम मेथड आप 100 एलिमेंट्स पे अप्लाई करोगे. सेम मेथड विल बी अप्लाइड फॉर 1000 एलिमेंट्स, right? So this means that we are going to apply the same method, same function, that is known as recursion. अब recursion को किसी इक्वेशन की फॉर्म में लिखना दैट इज नोन एज अ रेकरेंस रिलेशन. फॉर एग्जांपल हम बाइनरी सर्च की बात करते हैं. सो बाइनरी सर्च मींस अगर आपके पास n एलिमेंट्स हैं तो हम एलिमेंट्स को डिवाइड करते हैं टू इक्वल पार्ट्स में बिकॉज वी कैन अप्लाई बाइनरी सर्च ओनली व्हेन द एलिमेंट्स आर सॉर्टेड. फॉर एग्जांपल बुक में आपको कोई पर्टिकुलर पेज नंबर ढूंढना है, pages of the book are sorted, or you are searching for a word in the dictionary. I know that nowadays no one is using that dictionary, जो standard dictionary होती थी. Now everyone is having the apps and we can search for a word on the Google. So definitely it's not there. तो I guess better example रहेगा हम book के pages को consider कर लेते. अगर मुझे पेज नंबर 1 2 3 चाहिए, बुक में पेजेस हैं 1 से लेकर 1000 तक, सो टोटल n पेजेस आर देयर. तो हम लोग क्या करते हैं, रेंडमली हम बुक को ओपन करते हैं फ्रॉम द मिड. दैट इज 1 to 100 और 1 to 1000 पेजेस आर देयर, तो हम बुक को ओपन करते हैं फ्रॉम द मिड. दैट मीन्स पेज नंबर विल बी 500. फिर हम देखते हैं कि जो रिक्वायर्ड पेज नंबर है वो लेफ्ट साइड पे होगा या राइट साइड पे. सो इफ द रिक्वायर्ड पेज नंबर इज 1 2 3, then I'll be just considering this part of the problem. Second part will be ignored. सबसे पहले हमने क्या किया, n एलिमेंट्स थे, अगर यहाँ पे हमने n की वैल्यू 1000 ली है, if n elements were there, the problem was divided into two equal parts. Two equal parts and each part is having n by 2 elements. फिर क्या करेंगे, if still the problem is large, basically recursion में we provide two things. One is the recursive statement and other one is the termination condition. If else की फॉर्म में लिखते हैं recursive program, if में हम लोग provide करते हैं what will be the termination condition, and in the else part we provide the recursive statement. Right? So recursive statement means it is going to make a call to itself again and again. तो अगर आप लोग termination condition नहीं लिखोगे, then your program may enter into a infinite loop. Right? तो जो execution है, जो control है, वो कहाँ पे चला जाएगा, infinite loop में, क्योंकि उसको बाहर आने के लिए कोई condition नहीं मिल रही. For that, it's very important to take care of the termination condition. So in a recursive program, we provide two conditions. One is the termination condition. And another thing is the recursive statement. दूसरी चीज जो हम यहाँ पे प्रोवाइड कर रहे हैं वो है recursive statement. Correct? Now, If we are making this call, so now half of the elements are discarded. हमें लेफ्ट साइड वाले एलिमेंट्स को एक्सप्लोर करना है. नाउ अगेन वी विल बी डिवाइडिंग दिस प्रॉब्लम इनटू स्मॉल एलिमेंट्स. सो n/2 की वैल्यू यहाँ पे आपके पास क्या आ गई? 500 पेजेस को स्टिल हम लोग डिवाइड कर सकते हैं जब तक अल्टीमेटली यू हैव टू एंड अप विद गेटिंग वन पेज. So again we will be dividing these 500 elements into two equal parts. So this will be, अगर total elements n थे तो यहाँ पे कितने हो जाएंगे? n/4. So it will be coming out to be 250 and 250. But we want 1, 2, 3. फिर हम half of the elements को discard कर देंगे. This way this method is followed. तो जरूरी नहीं होता कि हर केस में हम कुछ एलिमेंट्स को डिस्कार्ड करेंगे. फॉर एग्जांपल हमें अगर 1000 एलिमेंट्स को सॉर्ट करना है, देन वी हैव टू वर्क ऑन बोथ द प्रॉब्लम्स. तो इट डिपेंड्स दैट व्हाट इज योर एप्लीकेशन फॉर व्हिच यू आर राइटिंग द एल्गोरिथम, और उसको सॉल्व कैसे करना है उसके बेसिस पे रिकरेंस रिलेशन इज गोइंग टू चेंज, right? So if we are working on both the parts of the problem, so we can say that here let us assume that function name is t and ये function हमें apply करना है n elements के ऊपर. So we are saying that here since the problem is divided into two equal parts और दोनों part के ऊपर same function apply करने, that is recursion. So same function I'm applying on the first part, same function I'm applying on the second part, प्लस कुछ एडिशनल टाइम जो इसको जो इस रिकर्सिव कॉल के अलावा चाहिए, चाहे वो आंसर रिटर्न करना है, चाहे डिवाइड करना है गिवन सेट ऑफ एलिमेंट्स को, व्हाटएवर एडिशनल ऑपरेशंस वी आर परफॉर्मिंग अपार्ट फ्रॉम द recursion, that is defined by f of n. That is some function. It can be polynomial function, logarithmic function, anything. So I can simply write this as 2t(n/2) plus f of n. This is a recursive statement. Recursive statement क्यों बोल रहे हैं? क्योंकि function खुद को ही call कर रहे हैं in terms of itself. Correct definition for the recursion is when a function is making a call to itself, that means function name should be same. यहाँ पे conditions क्या आती हैं आपके पास? Function name should be same. Number of parameters भी same होने चाहिए. Number of parameters are also same, but parameter value should change. क्योंकि अगर value भी change नहीं होगी तो इसका मतलब फंक्शन भी वही है, वैल्यू भी वही है, तो ऑब्वियसली वो कभी भी टर्मिनेशन कंडीशन पे नहीं जाएगा एंड हेंस विल एंड अप बाय गेटिंग अ इनफाइनाइट लूप. सो बट पैरामीटर वैल्यू शुड चेंज. तो अगर आप इस केस में देखोगे हमारे पास फंक्शन नेम सेम है, दैट इज t of n. नंबर ऑफ पैरामीटर्स एक है, यहाँ पे भी एक ही है. पैरामीटर वैल्यू इज चेंजिंग, यहाँ पे n है, यहाँ पे n/2 है. सो दिस इज अ करेक्ट डेफिनेशन. सो वी कैन से दैट दिस इज अ रिकर्सिव स्टेटमेंट. इसके अलावा और क्या डिफाइन करना है? वी हैव टू डिफाइन the termination condition. So let us assume that termination condition is अगर एक ही एलिमेंट बचता है, if n is equal to 1, ये कब तक हम प्रॉब्लम को डिवाइड करेंगे? until and unless we end up by getting single element. अगर एक एलिमेंट आ गया then directly we can return the answer. अगर एक ही एलिमेंट है तो directly we will compare it with the required page, and if it's there then we'll simply return it. So no iteration, no loop, nothing is required. So that is taking the constant time. Anyhow, we'll not focus on writing the recurrence relation for this session. Okay, definitely हम पूरे algorithms में recurrence relations लिखेंगे जहाँ पे भी recursion apply कर सकते हैं. And after that when we have to find out the complexity, तो मैं फिर उस पे solve करके नहीं बताऊंगी. So you have to get comfortable with solving the recurrence relation. हम total 3 methods cover करेंगे. तो ये पहला method है. ये इसको हम बोलते हैं When we are writing a recursive program in a form of relation, ये हमने relation की form में लिखे जहाँ पे आपके पास दो equations आ रही हैं, so this is known as recurrence relation. ये समझ में आया कि recurrence relation क्या होता है? So a recurrence is an equation that describes a function in terms of its value on smaller inputs. Number of elements क्या हो रहे हैं? कम हो रहे हैं, so it is the smaller input. Make sense? There are three methods for solving the recurrence relation. One is the substitution method, जो हम आज cover कर रहे हैं. Remaining are the recursive tree method and the Master's theorem. कल हम लोग Master's theorem और extended Master's theorem की बात करेंगे. We'll also talk about extended Master's theorem क्योंकि Master's theorem में कुछ constraints है, कुछ conditions है. So it is not applicable on all the cases, although in order to get the answer, first preference will be given to the Master's theorem because Master's theorem को solve करने के लिए बहुत कम time चाहिए, but condition is कि यहाँ पे हम हर case में Master's theorem apply नहीं कर सकते, so definitely we have to learn the concept of substitution method. Okay, so let's start with the substitution method. What do you understand by the term substitution? हम substitution method की बात कर रहे हैं तो obviously it is somewhere related to the substitution. Substitution means आप एक term की value find कर रहे हो और equation में जहां पे भी वो term आ रही है you are putting that value and finally आपके पास कोई equation बन जाती है. जैसे mathematics में अगर आपको कोई दो variables given है, some equation is there and you have to find out the answer for the variables. The value for the variables, then we are going to substitute the value of one variable in terms of the other variable. Correct? Yes? So that is the substitution method. So let's start. Let's consider one example. We have a recurrence relation T of n is equal to T of n minus 1 plus n, and it is returning 1 if n is equal to 1. So we can see here we are given with the recursive statement as well as the termination condition. So this is the recursive statement and here we have the termination condition. Start कहाँ से करेंगे? Obviously we'll start from the recursive statement. Okay, order of n square, that's fine. अब इस recurrence relation पे जो लोग already recursion का concept cover कर चुके हैं, solving the recurrence relation तीनों method से कर चुके हैं, तो definitely you can observe here is we cannot apply Master's theorem here. Correct? हम यहाँ पे Master's theorem apply नहीं कर सकते. Very good evening, Nishu. Can we apply Master's theorem? This is the question. जिन लोगों का those who are comfortable with Master's theorem, जिन्होंने नहीं किए कल से आप लोग भी आंसर्स देने लग जाओगे. यहाँ पे हम मास्टर्स थ्योरम में अप्लाई कर सकते हैं. वी कैन नॉट अप्लाई इट, राइट? तो इसका मतलब हम यहाँ पे क्या करेंगे? वी विल बी गोइंग फॉर द सब्स्टिट्यूशन मेथड. सो विल स्टार्ट फ्रॉम द रिकर्सिव स्टेटमेंट. रिकर्सिव स्टेटमेंट गिवन है आपको t ऑफ n minus 1 plus n. I want to substitute the value. ये फंक्शन है जिसको सॉल्व करना है. t of n minus 1. I want to substitute the value for t of n minus 1. First question है तो अलग से लिख लेते हैं. t of n minus 1. What will be the value for t of n minus 1? Observe here, अगर यहाँ पे n given है तो यहाँ पे n minus 1 है. That means we have to subtract 1 from whatever it is given here. So if it is n minus 1 it comes out to be t of n minus 2. और अगर यहाँ पे n है then it is saying plus n. So it comes out to be plus n minus 1. ये समझ में आया? So इस तरीके से हम दो तीन टर्म्स की वैल्यू फाइंड कर लेंगे. t of n minus 2 comes out to be t of n minus 2 minus 1, that is minus 3, plus n minus 2. t of n minus 3, this way we can find out the values n minus 4 plus n minus 3. अब क्या करना है, वैल्यूज तो फाइंड कर ली, सब्सटीट्यूशन मेथड है तो ऑब्वियसली सब्सटीट्यूट करेंगे. लेट अस अज्यूम दैट दिस वाज द फर्स्ट स्टेप. नाउ हियर वी आर गोइंग टू सब्सटीट्यूट द वैल्यू ऑफ t n minus 1. यहाँ पे आपके पास दो टर्म्स आ रही हैं, सो write both the terms t n minus 2 plus n minus 1. t of n minus 1 की वैल्यू सब्सटीट्यूट होगी, बाकी की सीरीज जो भी है वो एज इट इज आएगी. दिस इज सेकेंड स्टेप. Now substitute the value of t n minus 2. This is t n minus 3 plus n minus 2. Value substitute करवाई t of n minus 2 के लिए, बाकी की terms as it is n minus 1 plus n 3. t of n minus 3 की value substitute करवा दो. कब तक सब्सटीट्यूट करवाएंगे, वी नीड सम टर्मिनेशन पॉइंट. ये तब तक सब्सटीट्यूट करवाएंगे जब तक आपको सीरीज समझ में नहीं आ जाती. जब आपको सीरीज समझ में आ गई उसके बाद विल ट्राई टू गेट द टर्मिनेशन कंडीशन, विल रिपीट दी स्टेप्स. ये स्टेप्स कब तक रिपीट करेंगे, जब तक हमारे पास टर्मिनेशन कंडीशन नहीं आ जाती. सो दिस इज n minus 2 plus n minus 1 plus n. This is step 4. So how many times should I repeat this step? यहाँ पे termination condition is given as t of n is equal to 1. और ये कब होगा, जब n की value 1 है. What we are saying is t of n will be equal to 1 if n is equal to 1. That means it is saying that t of 1 will be equal to 1. This is what we are getting from the termination condition, right? तो कितने times इस step को repeat करेंगे ताकि termination condition आ जाए? इन टर्म्स में कोई प्रॉब्लम नहीं है क्योंकि ये रिकर्सिव फंक्शन कॉल्स नहीं है. रिकर्सिव फंक्शन कॉल ये है, इस टर्म को जो ब्रैकेट के अंदर आ रहा है इसको 1 कर रहे हैं, तो n में से हम कुछ सब्ट्रैक्ट कर रहे हैं. सो व्हाट शुड आई सब्ट्रैक्ट फ्रॉम n? n में से ऐसा क्या सब्ट्रैक्ट करेंगे कि आपके पास 1 आए? एनीवन? व्हाट शुड आई सब्ट्रैक्ट फ्रॉम n सच दैट द रिजल्ट कम्स आउट टू बी 1? हरिया 10 है, 10 में से क्या सब्ट्रैक्ट करेंगे कि रिजल्ट 1 आए? 10 में से 9 सब्ट्रैक्ट करेंगे. इफ इट इज 50, 50 में से 49 सब्ट्रैक्ट करेंगे. इफ इट इज 100, 100 में से 99 सब्ट्रैक्ट करेंगे. दिस मीन्स दैट n में से वी नीड टू सब्ट्रैक्ट n minus 1 from n to get 1 as the result. n में से फर्स्ट स्टेप में 1 सब्ट्रैक्ट कर रहे हैं, स्टेप 2 में वी आर सब्ट्रैक्टिंग 2, स्टेप 3 में वी आर सब्ट्रैक्टिंग 3, स्टेप 4 में वी आर subtracting 4. So this means that here we will be repeating this step for n minus 1 times. So ultimately it comes out to be, जब n minus 1 steps है तो n minus, and here we'll be writing जो भी स्टेप है उसको सब्ट्रैक्ट करवा रहे हैं. करेक्ट? Yes, or simply that's also a good way. So आप लिख सकते हो n minus k, n में से कुछ k times आप step repeat करवा रहे हो. We want the answer as 1. तो k की वैल्यू क्या होगी? You can calculate it. So k will be equal to n minus 1. तो both are correct ways. आप k consider करके कर लो. Yes, so k is the number of iterations. तो आप k substitute k consider करके देख लो कि हम k time step को repeat करें and you get the value of k. So this means that we have to repeat this step for n minus 1 times. So it comes out to be t of 1 plus, इससे पहले वाली term is 1 less than the previous one, n minus 3 and so on. This way will be getting n minus 2 plus n minus 1 plus n. So this comes out to be t of 1, n minus n is cancelled, t of 1 plus 2 plus 3 and so on. आपके पास एक series बन गई. Can you tell me that what series is this? Plus n minus 1. बच्चे कौन सी series है ये? Sum of first n natural numbers. Very good. So this term is 1. So ultimately we are getting 1 plus 2 plus 3 plus and so on up to n. And this is nothing but this is sum of first n natural numbers. What is the formula? हमारे पास कुछ limited formulas है in natural numbers. Yes. So formula is 1 plus 2 plus 3 up to n. Sum of natural sum series is it's n into n plus 1 divided by 2. And this can be written as 1 by 2 n square plus n. जब भी हम time complexity return करते हैं, we ignore the constant, so this can be ignored. And it's always written in terms of the greater function. Quadratic or linear function में obviously quadratic function is greater, so we can say that time complexity for this recurrence relation comes out to be n square. This is the answer. So what we have learned from this example, जब भी आपको substitution method से time complexity find करनी है, जो भी आपको recursive statement given है, start from that, keep on substituting the values जब तक आपको कुछ series समझ में नहीं आ जाती, and identify that how many times do we need to repeat the step in order to reach to the termination condition. And finally जब आप substitution करोगे, you will come out with the series. Okay, ये सारी वो series होंगी जिनसे आप already familiar हो, आपने mathematics में की हुई है. Just try to solve that series and return the time complexity. Okay, simple. I guess कुछ भी नहीं है. It's very simple. The only thing required is the practice. Next one, t of n is given as t of n minus 1 into n if n is greater than 1, and it is 1 if n is equal to 1. So here we are given with the term recursive statement. This is the recursive statement, and this is the termination condition. First 4-5 questions I'll be doing, and after that आप लोग try करोगे, and then we'll have the discussion. So we'll start from the recursive statement. मैं अलग से values नहीं लिखूंगी because we know that how we are going to substitute the value. So it is t of n minus 1 into n. This is step 1. Next, termination condition is given as t of 1 is equal to 1. This is the termination condition. Substitute the value of t of n minus 1. It is t of n minus 2 into जो भी आपके पास term है, हमने value n minus 1 की substitute की है, so it is into n minus 1 into n. This is step 2. Again substitute the value. It comes out to be n minus 3 into n minus 2 into n minus 1 into n, and this is step 3. Here also we'll be repeating this step for how many times? It's just similar to the previous reconciliation. The only thing that I have changed here is इससे पहले वाले reconciliation में हमने plus लिया था और plus की जगह पे यहाँ पे मैंने multiplication कर दिया. Okay, so we'll be repeating this step for n minus 1 times. Is it will give n factorial? क्या जब आप time complexity return करते हो आप n factorial दोगे? n factorial is yes, series जो बनेगी आपके पास factorial series बन रही है, but asymptotically n factorial is equal to what? Exactly, asymptotically it's not n factorial, so just identify that what is n factorial. Yes, very good, Mishu. It's n raised to power n. So we are repeating this step for n minus 1 times into n minus 2 into n minus 3 and so on into n minus 2, n minus 1 and n. Now it's up to you. n को आप n minus 0 लिख लो, कोई problem नहीं. Now it's up to you whether you want to elaborate it. आप इसको elaborate कर सकते हो. जब आप simplify करोगे, this comes out to be t of 1. t of 1 is nothing but that is 1 only. 1 into n minus 2 is 2 into 2 into 3 and so on. We are going till n. n minus 1 into n. So we know that n factorial is nothing but n into n minus 1 into n minus 2 and so on. This way it will be going to 1. So this is n factorial, this is one way. Asymptotically जिन लोगों को पता है, this is nothing but n factorial is asymptotically equal to n raised to power n. ये n raised to power n कैसे आया? To understand that here this is 1, इसको इग्नोर कर सकते हैं. तो यहाँ पे जब आप फर्स्ट टर्म देखोगे n into n into n into n into n, this is multiplied for n minus 1 times. तो अगर n को 2 बार मल्टीप्लाई करते हैं तो आपके पास आता है n square. 3 बार मल्टीप्लाई करेंगे it comes out to be n cube. So definitely if I am going to multiply it for n times, it comes out to be n raised to power n. So basically from here we are saying that n factorial is equal to order of n raised to power n. This is asymptotically equal to n raised to power n. ये समझ में आया? तो आपको अलग से n factorial और इसको elaborate करने की जरूरत नहीं थी. आप कोई भी टर्म लेके देखो. For example, we have n into n minus 1. So this is coming out to be n square minus n. So ultimately we are going to return the answer in terms of the greater function. So you need not to elaborate, you need not to write these two steps. Directly यहाँ पे देखो कि जो multiplication करके term आएगी, what will be that? Make sense? So undoubtedly here the answer is it's order of n raised to power n. ये समझ में आया? इससे पहले वाले क्वेश्चन में हमारे पास नेचुरल सम सीरीज बनी थी. Here we are getting the factorial series. Anyone having any doubt how we are getting the series? किसी को कोई डाउट कंफ्यूजन कि ये सीरीज कहां से आ रही है, कैसे आ रही है? I'm going to take the next set of questions जिसमें हम कुछ recursive function लेंगे which is dividing the elements. Okay, यहाँ पे हमने divide नहीं किए. So next one is t of n is equal to t of n divided by 2 plus c, and this is going to return 1 if n is equal to 1. Can we apply Master's theorem on this reconciliation? If n is greater than 1, can we apply Master's theorem? Those who are comfortable with Master's theorem, जिनको तीनों methods आते हैं, क्या आप बता सकते हो कि इस reconciliation को आप कौन से method से solve करना prefer करोगे? This is a recursive statement and this is a termination. Yes, we can apply. So what will be the time complexity? Termination condition. मास्टर्स थ्योरम में तो 2 ही स्टेप्स फॉलो करने. टाइम कॉम्प्लेक्सिटी के आगे आई गेस कुछ लिखने की भी जरूरत नहीं है ना? So what will be the time complexity? Order of log n. Very good. Yes, answer will be log n. But I'm not going to solve it using Master's theorem. I'm going to solve it using the substitution method. So it is saying that t of n is equal to मास्टर्स थ्योरम. डोंट वरी, जिन लोगों को नहीं आती है हम लोग कल करने वाले हैं और आपको काफी अच्छा लगेगा कि अननेसेसरली हमने इतना तामझाम किया सब्स्टिट्यूशन मेथड में, व्हिच इज एक्चुअली नॉट रिक्वायर्ड. ओके, सो t of n is equal to t of n by 2 plus c. दिस इज स्टेप 1. स्टेप 2 में क्या होगा? अगर n एलिमेंट्स हैं then we are saying that we are taking half of the elements, right? N by 2 is half of the original elements plus c. C means some constant value which is not dependent on the value of n. Constant means कोई फर्क नहीं पड़ता कि n की वैल्यू 1 है, 100 है, 10,000 है, 1 million है. It does not matter. It is independent of the size of the problem. Now, if I want to find out the value of n by 2, this comes out to be t of half of the elements, whatever we are writing here, so it is n by 2 plus c. So I can say that this is nothing but n by 2 square plus c. Similarly, t of n by 2 square will be t of half of the elements, जो भी आपके पास प्रॉब्लम साइज है उसके half elements लेने plus c, so this comes out to be t of n by 2q plus c. So we know that what to do with these terms, so we are going to substitute the values here. T of n by 2 is nothing but n by 2 square plus c, और एक पहले से आ रहा था plus c, so ultimately it comes out to be n by 2 square plus 2c. This is step number 2. Next one, t of n by, now I am going to substitute the value of t n by 2 square. It will be t of n by 2 cube plus c, and 2c already are hai, so it comes out to be 3c. Third step. And so on. अगर आपके पास यहाँ पे 1 है तो 2 raised to power 1 है, n by 2 raised to power 1. If it is 2, then it is 2 raised to power 2. If it's third step, then we are getting 2 raised to power 3. So if we are going to repeat this step for k times, so here we'll get n by 2 raised to power k. And if it's the third step, then we are writing it's 3c. If it's the second step, we are writing it's 2c. If it's the first step, we are simply writing c. So if the step is repeated for k times, so we'll write here k into c. Yes? Now we need to simplify this, because in the original problem, whatever problem is given to you, there we are just having the variable n. K हमने introduce करवाया, so this means that our answer should not include k. Okay, so let's find out the value of this k. It is simply giving here this term according to the termination condition. This is t of 1 is equal to 1. This means that हमें ये जो term है यहाँ पे 1 चाहिए. What we need here is n by 2 raised to power k should be equal to 1. From this equation, we can find out the value of k. So we can write this as n is equal to 2 raised to power k, but मुझे k की value चाहिए, so I'll be taking the log on both the sides. Take log with the base 2 on both sides. अब कल वाले सेशन में मैंने आपको कुछ logarithmic formulas दिए थे, so we'll be just using that. So I'm applying log on both the sides. This is log 2 raised to power k. So finally that comes out to be log base 2n. Yes, so what we have done is we have substituted this value to be equal to 1 plus k into c. So t of 1 is 1, k की value हमने find कर ली, that is log base 2n, और साथ में हमारे पास multiplication में c आ रहा है, that is the constant. So we can ignore this constant. This is just value 1, this is constant, and this is dependent on log n. So what is the greater function? Obviously that is log n. So we can say that the time complexity for this recurrence relation is it's log n. Make sense? So it is coming out to be log n with the base 2. अगर यहाँ पे divide by 3 कर रहे होते, we might be getting with the base 3. So usually they don't ask for the base, but in 2022 one question was asked, and वहाँ पे आपको ये substitution method ही use करना था, और जो options दी हुई थी, 2 options were very similar, like log of log n, बट उसमें सिर्फ चेंज कहाँ पे आ रहा था? बेस में. एक में दिया हुआ था फर्स्ट लॉगरिथमिक टर्म का बेस b है, सेकंड का a है. In another option it was given that the base for the first logarithmic term was a and then b. So you need to understand that how we are getting this base. Okay, is this clear? Anyone having any doubt? So next question आप लोग try करोगे? You wanna try the question or you want me to solve it? Okay. So next recurrence relation is t of n is equal to 2t n by 2 plus C, and this is equal to 1 if n is greater than 1 if n is equal to 1. Can we apply Master's theorem? Definitely yes. So what should be the answer that we'll be getting here? We are given with the recursive statement. We are given with the termination condition. Termination condition, and termination condition is given as T of 1. If n is equal to 1, then we will be getting 1 as the result. 1 will be returned. What should be the answer? जिनको मास्टर्स थ्योरम आती है अप्लाई करनी, they can give the answer with the master's theorem. Others can try it with substitution method only. Start from the first step. T of n is equal to 2tn by 2 plus c. This is step 1. If I need to substitute the value of tn by 2, this is bit trickier than the previous one. tn by 2 की value क्या आएगी? This will be equal to 2 as it is आएगा, इसका n से कोई लेना देना नहीं है. So 2. If here we have n, we are taking half of the elements, so it's already n by 2. We'll be getting here n by 2 square plus this is c. So we have to follow the same format. If I'll be finding the value of n by 2 square, this comes out to be 2. Half of n by 2 square, that will be n by 4 square, and f of n is independent of the number of elements. So just substitute the values here. ये 2 as it is रहेगा क्योंकि हमें value किसकी substitute करनी है? We are substituting the value of this term. So this 2 will be coming as it is. tn by 2 की value में हमारे पास दो terms आ रही हैं, so we'll be taking both the terms. It's 2t. I'm taking both the terms, okay? 2tn by 2 square plus c. This is the value for tn by 2 plus c. Simplify it. This comes out to be 2 square t n by 2 square. Brackets को आपने open किया. So n by 2 square plus 2 into c, 2c plus this is c. This is step 2. 2 square होगा. I'm so sorry. Half of the elements n by 2 square, so it is 2 cube. Thank you for pointing out. So half of the elements, so this comes out to be 2 cube. Okay. Now we'll substitute the value here. tn by 2 square की value substitute करनी है. So we have 2 square. Substitute the value of tn by 2 square, that is 2tn by 2 cube plus c, और बाकी की terms as it is आएंगी. This is 2c plus c. Let's simplify this. This comes out to be 2 cube. 2 square into 2 is 2 cube. T n by 2 cube plus 2 square will be multiplied with the second term of the bracket as well. 2 square into c plus 2 raised to power 1 into c, and we can write this as 2 raised to power 0 into c. Right? This is step 3. If we are going to repeat this for k times, so here we'll get 2 raised to power k t n by 2 raised to power k. Just observe the pattern. If it is 3, then यहाँ पे जो series start हो रही है, this is from 2, so it comes out to be 2 raised to power k minus 1 into c plus 2 raised to power k minus 2 into c, and so on. This way we are going till 2 raised to power 0 c. I guess it's going behind my image. So for a minute, let me switch it off. Okay. Now we are given with the termination condition. हमें क्या चाहिए? We want this term to be equal to 1. तो यानी कि n by 2 k को will consider n by 2 raised to power k will be equal to 1. From here we can find out the value of k. So k comes out to be log base to n, just like the previous question. Okay. So substitute the value here. 2 raised to power k किसकी equal है? हमें सारी की सारी terms n की form में चाहिए. 2 raised to power k is equal to n. This is t of 1 plus 2 raised to power k minus 2, or you can simply keep this as it is as of now. So let's solve the series first. यहाँ पे कौन सी series बन रही है? What series are you getting here? So this comes out to be 2 raised to power k. And from all these terms, इन सारी terms में से हम c common ले सकते हैं. So c common, and I'm writing this as a plus b plus c can be written as c plus b plus a. तो मैं इसको लिख रही हूँ 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 and so on. यहाँ पे c common निकलने के बाद we are having 2 raised to power k minus 2 plus 2 raised to power k minus 1. सब कुछ सॉर्टेड है, सिर्फ हमें ये आइडेंटिफाई करना है कि कौन सी सीरीज बन रही है. सो व्हाट सीरीज आर वी गेटिंग हियर? What series are we getting here? This is nothing but here the common ratio is same, so we are getting the GP series. And what is the formula for sum of GP series? This is sum of GP series. Let's discuss the formula for sum of GP series. Sum of GP series. What is that? In the GP series, we need to identify the first term of the series. First term, I'm representing this first term with a variable a. We need to get to know the value of common ratio. GP series होती है जब आपके पास terms में common ratio same आ रही है. Common ratio को I'm representing with R. Number of terms in a series is number of terms in series is, let's say it is represented by n. तो हमारे पास दो formulas होते हैं. If common ratio is greater than 1 and another one is if the common ratio is less than 1. So if the common ratio is greater than 1, then S of n, sum of all the n terms of a GP series is a r raised to power n minus 1 upon r minus 1. And if r is less than 1, so we get sum of n terms is a 1 minus r raised to power n upon 1 minus r. Correct? So if this is clear, then simply identify here we are getting a GP series. So what is the first term for this series? First term of the series is, this is 2 raised to power 0. That means we are getting the value of a as 2 raised to power 0, that is 1 only. Common ratio here is, it's 2. 2 divided by 1 is 2. 2 square divided by 2 is 2. So common ratio is 2. Number of terms in this series are 0 से लेकर कहाँ तक जा रहे हैं? K minus 1. This means that number of terms are equal to K. तो कौन सा formula apply करेंगे? We'll be applying the first formula. First formula is S of n. Here, since the common ratio is greater than 1, so we'll be applying the formula r raised to power n minus 1 upon r minus 1. Substitute the values. So here we are getting 2 raised to power k. ये term तो series से वैसे ही बाहर है, plus c. Instead of this whole equation, we are going to substitute this value. A is 1, r is 2, number of terms are k minus 1 upon 2 minus 1. 2 raised to power k plus c, and here we are getting 2 raised to power k minus 1. You can substitute the value for 2 raised to power k. 2 raised to power k is 2 raised to power k is n. तो यहाँ पे हमने वैल्यू ले ली. It is n plus c into n minus 1. So what is the maximum term? It's the linear function. So we can say that t of n is equal to order of n. So order of n is the final answer. Okay, I'm writing here in the rightmost corner, right bottom corner, because I didn't have the space above. So answer for this reconciliation is order of n. तो कुछ भी नहीं कर रहे. You must have noticed one thing. Everywhere we are just substituting the values to get the series, and after getting the series, we are just solving that particular series. Okay. Simple, comfortable. Are you all comfortable with the substitution method? If yes, then let's go to the next reconciliation. I'm just making little modifications to the reconciliation, and we are coming with different series. So you have to be very, very comfortable in getting the series and to solve the series. Next one. Reconciliation is t of n is equal to 2t n by 2. In the previous case, we took constant. Now I'm taking here n. This is 1 if n is greater than 1, if n is equal to 1. What should be the answer? जो मैं पूछ रही हूँ आंसर क्या है इसका मतलब, और those who are returning the answer, that means they are applying the master's theorem, right? क्योंकि orally और quickly हम master's theorem से ही आंसर दे सकते हैं. So definitely here also we can apply the master's theorem. This is the recursive statement. Start solving from the recursive statement. Substitute the values. You have 1 minute to give it a try. Termination condition. So termination condition is given as t of 1 is equal to 1. Anyone can return the answer using master's theorem? Or you guys are trying with the substitution method? So here we'll be getting t of n is equal to 2t n by 2. This is the starting point. That is the recursive statement itself. 1. Master's method is good, obviously. So what should be the answer? Do you know how master's theorem works? Anyhow, tomorrow we'll be talking about master's theorem only. सब्स्टिट्यूशन मेथड भी बेटा डिस्कस करना जरूरी था क्योंकि हर जगह पे हम मास्टर्स थ्योरम अप्लाई नहीं कर सकते. मास्टर्स थ्योरम के कुछ कॉन्स्ट्रेंट्स है जो हम कल वाले सेशन में डिस्कस करेंगे. सो दैट्स व्हाई फर्स्ट ऑफ ऑल वी आर कवरिंग द सब्स्टिट्यूशन मेथड. मास्टर्स थ्योरम डेफिनेटली हम लोग कल करेंगे. इनफैक्ट आई विल डिस्कस द एक्सटेंडेड वर्जन ऑफ मास्टर्स थ्योरम एज वेल. 2t n by 2 plus n. No answer, so let me solve it for you. So here we have to substitute the value of t n by 2. ये term as it is आएगी, so it will be 2t n by 2 square plus, now this is dependent on the variable of the function. अगर यहाँ पे n है तो यहाँ पे plus n कर रहे हैं. अगर t n by 2 की value find कर रहे हैं तो it will be plus n by 2 and this is plus n. Simplify it, it comes out to be 2 square t n by 2 square plus 2 into n by 2, तो ये आपके पास n आएगा, plus n and plus n. So ultimately this comes out to be 2 square t n by 2 square plus 2n. This is the output after the second step. Substitute the value here for Tn by 2 square. So it will be 2 square T n by 2 cube plus n by 2 square. Yes, Nishu, n log n will be the right answer. N by 2 square. Baki ki term as it is plus 2n. So it comes out to be 2 cube. This was 2. So 2 square into 2 is 2 cube. Tn by 2 cube plus 2 square into n by 2 square से 2 square cancel हो जाएगा. So it comes out to be n plus 2n is 3n. Have you observed the pattern? First step में अगर n in the recursive term we are getting 2 raised to power 1 and it is 1 into n. अगर second step है तो raised to power 2 है plus 2n. अगर third step है तो 2 raised to power 3 with 3n. So if we are repeating this step for k times, so we'll be getting this as 2 raised to power k. आपको कब तक वैल्यू सब्सटीट्यूट करनी है? जब तक आपको सीरीज का पैटर्न समझ में नहीं आ जाता तब तक आप वैल्यू सब्सटीट्यूट कर सकते हो. यूजुअली थर्ड स्टेप तक समझ में आ जाते हैं, सो यू कैन स्टॉप देयर एंड रिपीट द स्टेप in order to meet the termination condition. So it will be 2 raised to power k Tn divided by 2 raised to power k plus k into n. Termination condition is given for t of 1. So this means that this term has to be equal to 1. T of n by 2 raised to power k is equal to 1. N is equal to 2 raised to power k and k is equal to log base to n. I hope अब तक आप इसके साथ comfortable हो गए होंगे how we are calculating the value of k. Now substitute the values here. So t of 1, this comes out to be 2 raised to power k T of 1 plus k into n. T of 1 is 1 only, so we get here 2 raised to power k plus k into n. Substitute कर दो value. 2 raised to power k is equal to n and k is equal to log n और साथ में क्या आ रहा है n. This is log n. Here we just have n and here we are getting n log n. So obviously n log n is greater than n. So we can say that t of n is equal to order of n log n. This is the answer. Right? So finally we are getting t of n is equal to order of n log n as the answer. अगर base पूछा है तो आप base बता सकते हो. Otherwise simply you can say time complexity for this recurrence relation is n log n. Clear? But please do take care of actually students की mistake कहाँ पे होती है. आप लोग यहाँ पे देखते हो t of n is equal to 2t n by 2. पहली बार में तो 2 consider किया, उसके बाद जब यहाँ पे value substitute करते हैं तो you are just directly writing it as t n by 2 square plus n by 2 something like this. अगर ये वाला 2 आपने miss कर दिया तो आपके पास proper series नहीं बनेगी. So take care of each and every point, every step, observe the pattern and then substitute the values. Okay? Otherwise और substitution method में कुछ भी नहीं है. Okay, so next one. T of n is given as t of n by 2 plus n. If n is greater than 1, it is equal to 1 if n is equal to 1. What will be the time complexity for this recurrence relation? We'll be solving 2 more and then we'll end our discussion. Try to get the answer. मुझे इस चीज से कोई फर्क नहीं पड़ता कि आप लोग सब्स्टिट्यूशन मेथड यूज करके आंसर दे रहे हो या मास्टर्स थ्योरम. Anyhow, you just need to know that how to solve a recurrence relation. That's it. T of n will be equal to T n by 2 plus n. Anyone who got the series? तो यहाँ पे आपके पास रिकर्सिव टर्म से पहले कोई भी कांस्टेंट नहीं है, सो वी आर गुड टू गो विद दिस. सो इट विल बी n by 2 square, बट यहाँ पे क्या आ रहा है, दिस इज n. सो अगर यहाँ पे n है, then we'll be getting n. If I'm substituting the value of n by 2, we'll be getting here n by 2. This is the term which is replacing t n by 2. So this is plus n. This is step 2. T n by 2 cube plus n by 2 square. These are the terms which are replacing the term t n by 2 square plus n by 2 plus n. This is third one. So we have observed the pattern. So I'll be repeating this for k times. And this is returning t n by 2 raised to power k. प्लस अगर यहाँ पे 3 है तो यहाँ पे सीरीज कहाँ से स्टार्ट हो रही है, 2 से. अगर यहाँ पे k है तो ऑब्वियसली दिस विल बी स्टार्टिंग फ्रॉम k minus 1 n upon 2 raised to power k minus 2, and this way it will be going till the last term by 2 raised to power 0. 1 plus 2 plus 3. ये सीरीज कैसे आई, I do not know. Obviously that is incorrect. So we want this term to be equal to 1. N by 2 raised to power k is equal to 1. N upon n is equal to 2 raised to power k, and k is equal to log base 2n. This we are getting because we are given that t of 1 is equal to 1. So that's why I am substituting this term to be equal to 1. So ultimately here we get t of 1, and I'm writing these terms. इस पूरी सीरीज में देखोगे तो न्यूमरेटर में n कॉमन आ रहा है, so we can take this n common. And here we are getting 1 upon 2 raised to power 0 plus 1 upon 2 raised to power 1 plus 1 upon 2 raised to power 2 and so on, plus 1 upon 2 raised to power k minus 2 plus 1 upon 2 raised to power k minus 1. इमेज के पीछे जा रहा है, थोड़े से क्वेश्चंस लेंथी होते हैं, so it requires more space. Okay, now what is the series? हमने अभी series डिस्कस की है. So what series are we getting here? We are getting a GP series. This is a GP series with first term as 1 upon 2 raised to power 0. That is nothing but 1. Common ratio is 1 by 2. And number of terms कितनी है यहाँ पे? 0 से लेकर raised to power k minus 1 तक जा रहे हैं. So number of terms are 0 to k minus 1 is k terms are there. So we are going to apply the formula. Which formula will be applying here? Here common ratio is 1 less than common ratio is less than 1. So we will be getting here 1 minus r raised to power n, 1 minus r. Substitute the values. So t of 1 is 1, n. First term is 1, 1 minus a common ratio is 1 by 2, and number of terms here we are getting is k, divided by 1 minus 1 by 2. Anyhow, 1 minus 1 by 2 is 1 by 2, which is a constant, and we can ignore the constant. So this is a constant. I'm going to ignore this because it's not going to play any significant role. So ultimately we are getting here is, I'm utilizing the space here. Okay, I'm coming here. So t of n is equal to, yes, order of n is the right answer. T of n is equal to 1 plus n, 1 minus, I can write 1 upon 2 raised to power k. Okay, so substitute this value here. It is 1 plus n, 1 minus 2 raised to power k is n. Just simplify this, is 1 plus n minus n divided by n. So ये cancel हो गया. So obviously we are getting a linear term. So we can say that t of n is equal to its order of n. So in this case, we are getting the answer as linear time complexity. Make sense? So here also we got a series. We identified that what series are we getting. We applied the formula for the same, and then we are returning its value asymptotically. Okay. Any doubt? Any questions? It's clear. All right. So last question for the day from substitution method, and this is what you guys are gonna solve it. T of n is given as t of n minus 1 plus log n, and this is 1. And all right, so if n is greater than 1, if n is equal to 1. Anyone want to give it a try? So here I have given you a recursive statement and the termination condition. Recursive statement और termination condition दोनों available है. Termination condition, substitute the values. So start with the first step. T of n is equal to t of n minus 1 plus log n. This is step 1. I'm going to substitute the value of t n minus 1. So it will be n minus 2. अगर n के लिए substitute कर रहे हो तो it is returning log n. If I'm substituting the value of n minus 1, so here we'll be getting log n minus 1 plus log n. This is step 2. This will be t of n minus 3 plus log n minus 2. Yes, n log n is the right answer. तो यहाँ पे हम मास्टर्स थ्योरम अप्लाई नहीं कर सकते थे because in denominator we do not have any term. So here we have to apply the substitution method only, n minus 1 plus log n. Have you observed the series? If yes, we are going to repeat this for k times. So here we'll be getting t of n minus k plus log n minus k minus 1 and so on plus log n minus 2 plus log n minus 1 plus log n. आप डायरेक्टली भी आइडेंटिफाई कर सकते हो कि n minus 1 टाइम्स रिपीट होगा, और अगर नहीं समझ में आ रहे यू कैन ऑल्सो कॉल दिस एज कि इट इज गोइंग टू रिपीट फॉर k minus k times. So this term has to be equal to 1 because this is given in the termination condition कि अगर t के साथ एक ही term है then it is equal to 1. So from this we are getting n minus k should be equal to 1. This means that k will be equal to n minus 1. So indirectly, ultimately, we land up by identifying that we have to repeat this step for n minus 1 times. Okay, directly कर लो या k की value लेके कर लो, it's up to you. So here we get t of 1 is plus this k minus 1, just substitute the value, it is n minus, okay, we are repeating this step for n minus 1 times, so it is n minus 1. So this comes out to be log 1 plus log 2, something like this, and so on up to log n minus 2 plus log n minus 1 plus log n. Now, yesterday we talked about one logarithmic formula that log a plus log b is nothing but that is log ab. So when we are going to apply here, यहाँ पे जितनी भी terms है सब में log के साथ addition आ रहा है. So this comes out to be 1 plus log 1 into 2 into 3. Ma'am, tomorrow Masters and Extended Masters Theorem will be taught. Tomorrow Masters Theorem, Extended Masters Theorem and Recursive Tree Method will be covered. N minus 2, N minus 1 and N. So 1 into 2 into 3 into 4 up to N, this is nothing but N factorial. So we get here N factorial. This is the series for, this is n factorial, or n factorial को हम क्या बोल रहे हैं? This is asymptotically equal to n raised to power n. So this comes out to be log n raised to power n, and this is nothing but 1 plus n log n. So obviously this term is greater. So here we get t of n is equal to order of n log n. Okay, this is the answer for this question. So we'll end our discussion here. I hope that you guys are comfortable with solving the recurrence relation using the substitution method. So tomorrow we'll be covering uh, recurrence relations using recursive tree method and Master's theorem. Master's theorem में हमारे पास दो cases आएंगे. एक आएगी basic Master's theorem and second one will be the extended Master's theorem. So we'll be covering both. I'll be starting the session from Master's theorem, because recursive tree method में nothing much is there. And those who are following this session on this channel for the first time, guys, you can join the Telegram group, that is Shefali ma'am Testbook. You can search for it, or you can simply go to the description of this video. I'm going to share my screen with you guys. Okay, I hope that it's visible to everyone. So here we have the video. जैसे आप इस वीडियो में आओगे, इसके डिस्क्रिप्शन में जाके first link is for the master class. In the master classes, we are solving the questions. These are free, so you need not to pay anything for these master classes. And after that, we have the NIC Super Coaching batch. This is specifically designed for the students, those who are preparing for NIC. And third link is for the GATE Super Coaching Telegram group. So you can join this Telegram group in order to get the PDF of this session. I'll be sharing this PDF in another 5 minutes in the group, ताकि आपको notes मिल जाए और आपको इधर उधर से topic cover करने की जरूरत ना पड़े. And if you want to cover the complete syllabus of GATE in detail, along with the notes, test series, everything, so for that we have super coaching. जैसे ही आप fourth link पे click करोगे, it will take you to the Testbook website, and here you can see the courses. We have all courses, full courses, subject courses. So I'm going to the full courses. Full courses means complete syllabus is there. So here there are 4 courses provided. One is by the Gate Forum, Digimento, Nimbus Learning, and Testbook itself. That is by me and my team. So here, if you go to this one, you can see a series of the recorded sessions. Okay, so under the series, you can see the demo classes, the sessions on the various subjects. So but as of now, this is under the law. Okay, because it's not subscribed, so it's under the law. So for that you need to get that subscription. Apart from that, test series is there, skill academy, and so on. So for this you need you can also go through the course curriculum and syllabus. Test series is also there. And okay, let me go to the previous slide. Here you can see the profile of the super teachers, you can attend the demo classes, you can see the upcoming sessions for the live series, mock test, and study notes. These study notes are provided in the detailed manner, and short notes which are known as the formula notes. ये beneficial है जब आप एग्जाम से पहले रिवाइज कर रहे हो, उस टाइम पे हम डिटेल नोट्स फॉलो नहीं करेंगे. डिटेल नोट्स में हर यूनिट के लिए एक पीडीएफ है. फॉर्मूला नोट्स में फॉर एवरी सब्जेक्ट देयर इज वन पीडीएफ that is containing 1 to 2 pages. That's it. So complete set of notes will be provided to you in the form of the PDF files. It's available for engineering mathematics, general aptitude, formula notes, computer science engineering. If I'm going to computer science engineering, you can see here notes for all the technical subjects are available, but as of now there is a lock. Okay. So to get all these benefits, actually super coaching में you will be getting the content in the recorded format, as well as जो detailed syllabus होगा that will be in the format of the recordings, and live series में we will be having the quick revision sessions. तो अभी इस time पे quick revision तो होगी नहीं क्योंकि batch has already started, तो not much syllabus has been covered, तो इसलिए quick revision अभी start नहीं हुई है. Once you are done with few subjects, so we'll start with a quick revision series, doubt sessions and previous year questions. तो ये सारे के सारे सेशंस लाइव सीरीज में आएंगे. हो सकता है अभी आपको लाइव सीरीज में कोई सेशन ना दिखे. दिस इज द मेन रीजन बिहाइंड दैट. एंड इफ यू वांट टू जॉइन दिस, then simply go to the pricing, and here you can see 3 plans are available: 1 year plan, 2 year plan and 3 year plan. 1 year plan is for the students, which is basically designed for targeting 4th year students or BTech pass outs, क्योंकि आपको एक ही साल काफी है, because you guys will be either working on the final year project जिसमें बहुत ज्यादा लोड नहीं होता है, तो आप अच्छे से टाइम दे सकते हो for the preparation. And next one is for a 2 year course. This is basically for the students which are in second year or third year. मैं जो final year students नहीं है, उसके अलावा जो second year third year के students, I'll recommend you to go for 2 year plan. Because second और third year के जो भी core technical subjects है, those will be covered in the GATE syllabus. वही है GATE syllabus में, you can go through the GATE syllabus, and this will help you in understanding the concepts and depth, क्योंकि GATE is all about the conceptual things. तो जब concepts आपने understand कर लिए, then there will be nothing more in the theory. आप easily theory cover कर सकते हो. तो सेमेस्टर एग्जाम्स में तो बेनिफिट होगा ही, गेट में भी होगा, कैंपस प्लेसमेंट्स, इसरो, डीआरडीओ, जो भी एक्स्ट्रा एग्जाम्स आ रहे, द मेन सिलेबस ऑफ द अदर एग्जाम्स आल्सो रिवॉल्व अराउंड द सिलेबस ऑफ द गेट. सो इफ यू हैव प्रिपेयर्ड ऑल योर टेक्निकल सब्जेक्ट्स thoroughly, then you need not to worry about cracking any exam. Okay. So this is about the various plans, and if you want to get the maximum benefit of it, so sorry, so you can apply here the coupon, and coupon code is given in the description box. You can see here the coupon code is Shefali, SHEFALIS. So this is all from my side. If you have any doubts or queries related to the concept, related to the syllabus, or anything, you can ask. So tomorrow I'll see you at the same time, that is at 6 p.m. and we'll be having the discussion over with other methods of solving the recurrence relation. So let me quickly share the schedule for the classes. Monday to Friday we are having the session on the YouTube and the masterclass. YouTube session time is 4 p.m. and masterclass is at 8 p.m. In the YouTube sessions we are covering the concepts. From Monday, this Monday, we will be starting with applications of divide and conquer, and we'll also learn that how to revise, how to write the reconciliation, and बिना complexity को याद किए भी आपको correct answers मिल सकते हैं. Okay, so we need to understand that concept, and master classes में हम लोग PYQ solve कर रहे हैं. Saturday and Sunday, I'm taking 2 sessions, one for the GATE aspirants. Both the sessions are on YouTube. This is for GATE aspirants, and the second session is for aspirants of the ISRO. जो लोग GATE की प्रिपरेशन कर रहे हैं वो भी ISRO वाला सेशन अटेंड कर सकते हैं. So the timing for this session is 6 p.m. and for ISRO it's 9 p.m. Okay, so this is all for this session. I guess there are no queries, so we are going to end this discussion here. I'll see you at 9 p.m. because today is Saturday, so we'll be having one more session at 9 p.m. Stay tuned. God bless you all. Take care. Bye bye.